Good day and hi. Our group will present for Reaction Engineering 2 project video. This video will be presented by me, Belinda Wong, Hua Hui Sin, Lim Sherong, Tan Yong Zhen, and Navijit Kaur. In this generation, researchers start looking for alternative energy like vegetable oils. In order to synthesize biodiesel as a clean burning alternative to diesel fuel, esterification of vegetable oils with methanol using acid and base catalyst respectively is invented. Several types of vegetable oils with a diversified composition in fatty acids can be used as the reactants of biodiesel production, such as soybean, sunflower, and palm oils. Moreover, the type of alcohol is suggested to use methanol as it allows the simultaneous separation of glycerol, and normally, methanol is the cheapest alcohol in the most countries. The end products of esterifications of vegetable oils are a mixture of fatty acid alkyl ester and glycerol.
The solid catalyst chosen for this experiment is strontium oxide. Strontium oxide is a solid-based catalyst. While calcium and magnesium have typically been employed in solid-based catalysis for the trans-esterification reaction, strontium oxide is said to be a better catalyst choice for biodiesel synthesis due to its stronger basicity and extraordinarily high reaction rates under certain fields of activation. The alkaline earth elements beryllium and radium cannot be utilized as catalysts due to their carcinogenicity and radioactivity, which leaves the remaining alkaline earth oxides, which are barium oxide, strontium oxide, calcium oxide, and magnesium oxide. Calcium oxide has been the most extensively investigated oxide for the trans-esterification reaction in the last 2 decades. However, its basicity and catalytic activity are still poor when compared to strontium oxide and barium oxide. Barium oxide is inappropriate for biodiesel synthesis due to its toxicity and high solubility in methanol. Despite being an efficient catalyst, homogeneous catalyst is not suitable because the separation from the mixture becomes a major issue. Therefore, heterogeneous catalysts such as strontium oxide are known as a better option in improving the trans-esterification process by removing the extra processing costs associated with homogeneous catalysis and lowering pollution generation. As for solid-base or solid acid, solid-base catalysts are said to have a higher catalytic activity. Solid base is preferred over solid acid because heterogeneous base catalysts are insoluble in the trans-esterification reaction system and it is easy to regenerate, therefore simplifying the downstream processing of biodiesel production. For the procedure for strontium oxide preparation, the figure shows the leaching of cell state with sodium sulfide at 20 degrees Celsius in order to prepare sodium sulfate. Then dilute hydrochloric acid is used for the acid leaching of sodium sulfate to form strontium chloride. The aqueous solution of strontium chloride reacts with sodium carbonate solution for the precipitation of strontium carbonate. The strontium oxide produced is of high purity.
I will be talking about the characterization techniques to investigate the chemical, physical, and morphological properties of strontium oxide. To determine the physical properties of strontium oxide, thermogravimetric analysis (TGA) is used. TGA is used to determine the thermal transition of sample. TGA is a good approach since it allows us to establish the appropriate working conditions for the catalyst, such as thermal stability, oxidation stability, and the projectile lifespan of the product. Besides that, to determine the chemical properties of strontium oxide, energy dispersive X-ray (EDX) is used. The elemental composition of materials can be determined using EDX. It will specify the composition of the strontium oxide and provide valuable information to choose a suitable support for the catalyst. In addition, to determine the morphological properties of strontium oxide, scanning electron microscopy (SEM) is used. It allows us to study the surface structure and morphological properties of the catalyst. SEM responds significantly quicker, is less restricted, and may sometimes be conducted with little or no sample preparation. Thank you.
Hi, I'm Lim Sherong. For this reaction engineering project, I will cover on the task 5, which is propose a suitable catalysis reactor for the production of biodiesel and provide a suitable diagram. One of the most suitable catalysis reactor that can be used to produce biodiesel is the catalytic membrane reactor. Membrane reactor is also known as a membrane-based reactive separator. One of the reasons that we choose for this catalytic is because it is an environmentally friendly process. It could reduce the usage of solvent and chemicals that are harmful to the environment. However, compared to the catalytic concentration in the conventional method, the use of catalytic in the catalytic membrane reactor is lower. The next is lower investment cost. Both separation and catalysis processes are combined in single unit operation, and the inert membrane do not require to separate two phases obtained after transesterification. So below is the diagram, which is the process flow diagram of transesterification reaction in catalytically active membrane reactor.
Now I'm going to present the trend of the production. The first step is feedstock production. Imagine we're using palm oil as the feedstock, and then we're going to the catalyst transesterification, which the alcohol is react with the triglyceride, and then we undergo the process of separation to separate the alcohol, the glyceride, and the catalyst. The last step is the purification. We purify the fatty acid methyl ester to meet the quality standard of biodiesel. To present the challenge of biodiesel production in Malaysia. The first challenge is a raw material challenge. The production of biodiesel in Malaysia is dependent on the palm oil. So when the palm oil demand is increased, the price of the palm oil will also increase, which causes our biodiesel is not economic feasibility. The next challenge is the waste management challenge. For information, the glycerol is also the core product of the reaction. Of course, it can be sold, but when the production of the glycerol increase, but the demand is still low, the price of the glycerol becomes worthless. And the third challenge is the water requirement challenge, because water is very important in refinery process and purification process. So when we build the plant, either we choose the location near the water resource, or we have to consider recycling the water. Either of the method is very costly.